The command pattern is an interesting one. Some will say it decouples invokers from actions, or that it allows to queue and undo operations, or centralize execution. Now, all of these things are true, but during my research I found out that it depends a bit on how you implement the pattern. Let me start by showing the simplest form of the command pattern. Look at this JavaScript function. It simulates saving a document. This line assigns the Save Document function to the button click handler. The Save Document function is assigned to the Save button. When the button is clicked, now in this diagram the Save Document function is the command and the Save button is the invoker. The command pattern also has a client that hooks everything up. So yes, this is already a very light version of the command pattern, but it has some limitations. First of all, assigning the command to a button happens at startup time. The consequence of this is that the button will always call Save Document in the same way. Now, this code leaves no room for sending arguments when the function is called. A second limitation is that each button on the screen invokes its own command. That way there is no central place to add undo, redo and logging functionality. No worries, we'll fix that soon. First, let me show you a slightly less light version. Now in this book, where the command pattern is described, the command could not be a plain function because the languages used here did not support functions as arguments. So they had to implement the command as a class. I'll rewrite the last example in Python and turn the command into a class. So here is the button that accepts a command. I'll create two command classes that implement an execute method. I'm not going to create a command interface yet to keep the code small. I create two buttons. As you see, the buttons receive command instances. Everything is hooked up very statically. I'll call the click methods. And that works. This version of the code is a bit closer to the traditional command pattern as described in the Gang of Four book, but we're not there yet. Notice that the commands are still very static. They are still hooked up at startup time and there is no way to send arguments when the button is clicked. And there's another problem. Notice how the commands execute the work to save and load documents. Now, this is fine for small projects, but the command pattern is not responsible for executing the work. Let me introduce another class. I will introduce class editor that executes the real work. The load command class gets an instance of editor. And instead of performing the work, execute delegates the work to editor. I do the same for save command. I create an editor and pass it to the commands. And that works. You are now looking at the classic command pattern from the Gang of Four book. Let me show you the UML diagram. The diagram is a bit overwhelming. Let me break it down. The command pattern has an invoker that executes the commands. In our system, each button is an invoker. A button depends on a command interface. In fact, each button stores an instance of one of the concrete commands. The concrete command has access to the editor to delegate the work. The editor is the receiver. The main script is the client that hooks up everything at startup time. This is the command pattern in its full glory. Now perhaps you have seen the canonical command pattern example, where remote buttons can switch off and on devices. What it achieves is that devices are decoupled from buttons and that the universal control can act as a central executor. And while that's a nice thing, it still misses an important feature, and that is parameterized controls. This video is a test recording of a chapter in my new course on software design. Now, during my research, I realized that many patterns and principles are very ambiguous because they have changed over the years. And I have a question for you. Do you like it when I try to clear up the confusion by showing you the history of patterns, like where they originated and how they evolved over time? Now, when you feel that helps, let me know in the comments and I will make the best possible non-ambiguous course out of it. So to make the traditional command pattern a bit more practical, we need to add two features: parameterized commands and a central execution bus to allow undo and logging. Let's go back to the idea of a text editor. I want to support commands that definitely will need arguments when executed. When typing on the keyboard, a command needs to insert the character at the cursor position, and deleting text or making it bold needs a text selection. And that means that the text area should be manipulated through a well-defined set of methods. Let's start with that. Here is class document. It creates an empty text attribute and has methods to insert and delete text. And here is the class editor. It takes and stores a document and has a method to render the text editor with the document text. I hook it up in main. Let's see if I can render an empty document. Yep, that works. Here is the UML class diagram. Editor receives and stores a reference to a document. This is a unidirectional association. Editor collaborates with document to perform its behavior. Now there's no UML aggregation or UML composition because editor and document do not form a whole part. We now have an empty document. Let's insert some text. And that works. One more. It works. Let me delete the last line. Very nice, our little editor is well on its way. Okay, that works, but the program has some weaknesses. Look at main. It uses its direct access to document to manipulate the text. Even if there is an editor class around the document, it does not protect the document in any way. If the document API changes, all callers break. So, what are my options here? The first thing I do is create cursor information in the editor. And I need a way to set the information. This will simulate moving the cursor and selecting text. Now I create a public method to insert text. As you see, it takes the editor cursor position and the passed content argument and delegates it to the document object. The public delete method won't need arguments at all. Insert and delete are controller functions that are called when a user types text or presses a button and will just pass the cursor information to the document delete method. I can now call the methods on editor in main. Let me check if that still works. It does. I'll delete the word world. Very nice. It is nice that main is uncoupled from the document API, but you might wonder what has been gained by all this. The insert and delete methods are nothing more than shadows of the document methods. At this moment, there is not a good reason to have such shallow methods. But that will change once we add undo functionality to the editor. But how would we achieve that here? A naive solution would be to store the text before each action. But when I think of it more, that would lead to a big memory consumption when the document grows. Instead of storing the full text, I want to store the action itself. Let me show you. The editor should have some action history list. After inserting, I store the insert position and inserted content. Later, I can use that data to undo the action. To undo a delete, I need more info. First, I let the document delete method return what will be deleted. So I can add it to the undo history. Just like with the insert information, I can later use it to undo the delete. I'll write an undo method. Interestingly, I can reuse the delete method for undoing an insert and reuse the insert method to undo the delete. The last action was deleting the word world. Let me undo that. There is the full phrase again. If I undo again, I should go back to the original state and see an empty document. Nice. Now, if I'm allowed to say so, I'm already impressed with our little text editor. But for it to be a true Markdown editor, it needs a lot more. But when we start adding more functionality, some problems will arise. First of all operations need to store undo information. And the editor needs to implement the undo logic for each method. Look at that nasty switch here. This is an open-close principle violation. Each time a new method is added to the document class, this switch needs to change with it. How can we fix this problem? Well, you guessed it. We use the command pattern. And this time we use parameterized commands and a central invoker to allow undo and logging. The command pattern will wrap functionality in commands. Let me show you. The first thing I do is make an interface for the commands. I'll make the insert command. I'll put it in a new folder. You might have noticed I hardly use type-ins here. I did that to dial down the noise in the code. Commands will use some type-ins however, so my IDE can watch over my shoulder if I implement everything correctly. Notice that the command does not have the logic to insert into the text. Instead, it delegates the execute and undo methods to existing document methods. I create the delete command. Command initializers accept and store all required information in order for the command to do its job. Now I need a method that executes commands and puts them on the history. The insert method will now instantiate an insert command and pass it to the executor. I do the same for delete. And the undo method can be drastically simplified. Let's check if everything still works. Yes, it does. Now, I can easily forgive you when you think this is quite some over-engineering. Main calls a public method in editor, editor creates and executes a command, the command delegates the work to the document object, and actually we should even separate the code more because editor is sharing three responsibilities: holding cursor information, executing commands, and housing the public methods that create commands. Such functionality is called a controller. But to prevent even more classes, I kept all functionality in the editor. Let me show you the UML class diagram. This UML class diagram represents the current project. Have a look at it, and then I'll strip it down to the basics of the command pattern. The invoker executes commands. Well, this depends on the command interface. In our project, the invoker also creates the concrete commands, and when executed, they are added to the history. Invoker and command have an association relationship. The invoker must have an instance of the receiver so it can be passed to the concrete commands. When a concrete command is executed, it delegates the work to the receiver. Client hooks everything up at startup time. Now, a small disclaimer is at place here. If you look up the command pattern according to the Gang of Four book, it will look a bit different because it assumes static commands that each are assigned to their invokers at startup time. This diagram maps out commands that are created on demand and are executed through a central command bus. At this point, I know what you're thinking. That was a lot of code for just the same functionality. What has been gained by this? Well, it's time to show the benefits of the command pattern. One thing that is easily overlooked is that the system has all use cases in a single folder. This is a project that shows intent, not technical structure. How about adding a third use case? Let's add an editor command to make text bold. I'll start with the new command. The command stores all information to make a selection bold. To execute, I use the existing insert method from document. To keep the code simple, I do not allow toggling bold. Regardless of the current state, it will always add new asterisks around the text. And to undo, I delete the inserted characters. I create a controller method in editor. Let's try it. I insert some text and run the code. Okay, nothing is broken. Now I make the word beautiful bold. Cool, that works. Let's test undo. Very nice. So let me ask you a question. We added a completely new editor function, and what code did we have to change? We did not touch document at all. It is closed for modification. However, we did need to change editor because it has three responsibilities, remember? Now, if you would encapsulate the controller to its own class, you can also lock down the editor class. As I said before, this will take us too far, and by now you start to understand where the real power of the command pattern is. It is the central invoker that acts as an execution pipeline where all commands must go through. Additional code can be inserted before and after execution. We've already added the undo functionality. How about logging? Let's log what functions are used in the system. Have a look at the controller. If I want to log the usage of these functions, I could add log statements in each method, right? Sure I can, but since all these methods create and execute commands, I have a central place to do that. I go to the command bus. That simple? Yep. Change your mind and want to see the command name and its parameters? No problem. I know setting up the command pattern is a lot of work, and to be honest, it can be overkill for small projects. But the benefits of having a central execution bus are very nice. Now, aside from logging and undo, you can build a command bus that can redo commands, puts them in a queue, retries them when they fail, or check authorization before executing a command, and handle errors in a central place. Such extra processes are known as cross-cutting concerns, functionality that is shared across your app. And your execution pipeline makes sure every function is handled uniformly. Now, the command pattern works great with user interfaces. You already saw a light version of the pattern with the JavaScript callback function. Microsoft's XAML platform allows you to bind classes that implement the iCommand interface directly to XAML buttons. But you will also find command line versions of the pattern, like Django's management module, which also uses the command pattern. Now, as you have seen in this video, there is no one command pattern. The pattern can be implemented in many ways, and you went on a journey from seeing a very light version to a rather advanced version with parameterized commands and a central command bus. I hope this video helped you.